Today I'm going to be teaching you about hybridization. Hybridization is the modification of localized electron models to account for the observation that atoms often seem to use special atomic orbitals in forming molecules. So with hybridization, you have three bonding orbitals, s, p, and d. Each orbital only holds a certain amount of valence electrons. So with s, you have one orbital. Each orbital contains two valence electrons. So s is going to have 2. P has 3 orbitals, each containing 2 valence electrons. So for a total of 6 valence electrons. And then D has 5 orbitals, each containing 2 valence electrons, for a total of 10 valence electrons in D. When deciding the hybridization, you want to start with orbital s and end with orbital d. So s has 1 orbital, p has 3 orbitals, and d has 5 orbitals. So, think of it as a grocery cart. When you're determining hybridization of an element or a compound, you want to start with your cheapest, which is s. And then move your way up to the second cheapest, which is P, and then your most expensive, which is D. So in the end, you want your grocery cart to cost the least amount as possible. So obviously you're going to use your S's first, and then your P's, and then go to your D's. Now I'm going to teach you how to find the hybridization of a single element. Today we're going to be using oxygen, so find it on the periodic table, and we're going to be using the valence electrons. So oxygen contains 8 valence electrons. So now we're going to draw the structure that we were drawing before. So S has 1 orbital, so 2 valence electrons have been used. Now we're going to draw P, which contains 3 orbitals, each containing 2 valence electrons, for a total of 6. 2, 4, 6, 8. So this has 6. So these together equals 8, which is our total amount of valence electrons that oxygen holds. So now going back to the grocery store metaphor, since we started with S because it's the cheapest, and then we went to P, which is second cheapest. Since we used all of S orbital, we're going to write S. And since we use all 3 of the p orbitals, we're going to write sp3. This is the hybridization of oxygen. Now, let's say if we had an element that didn't have 8. So let's say we had nitrogen. So nitrogen contains 7. So now, we're going to write S, 1, 2, so that's 2, and then P, 3, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. So you've used all of your S, then the S1, but you only used 2 of your P's, so it's going to be SP2. So your hybridization would be sp2 for nitrogen. Next, I'm going to teach you how to find the hybridization of a compound. The compound we're using today is H2O, which is water. So when you're doing it of a compound, you're going to do the Lewis dot structure. So you're going to look at the number here. So hydrogen has 1. And then you're going to go over to oxygen, and it contains 6. So since you're going to have 2 hydrogen and 1 oxygen, you're going to have a total of 8. So now you're going to draw the Lewis dot structure for this. So H, oxygen is going to be your central atom. Hydrogen only has 1 valence electron. You're going to share it with oxygen. So now you need to get a total of 8. Right now you have 4, so 5, 6, 7, 8. 2 unpaired, and then 2 bonding. So for a total of 4. So back to the grocery cart metaphor, you're going to use your S's first. So there's S1. So S can have 1, P can have 3, and D can have 5. So since we have 4, we're going to use the S first. So S, cross out this, and we have 3 left. So we're going to use all of our P's to end with the hybridization of sp3 for H2O. The next compound I'm going to teach you how to find the hybridization for is BrF3, bromine and fluorine. So find bromine on the periodic table, contains 7, and then fluorine on the periodic table also contains 7. So you're going to have 3 fluorine and 1 bromine for a total of 28. Now you're going to draw the Lewis-Dot structure again with Br as your central atom, fluorine, and fluorine. Fluorine contains 7. It's going to share 1 with bromine on every single one. Bromine can contain more than 8 electrons. So now you get for a total of 28. So right now we only have 24. So 25, 26, 27, 28. So you have 2 unpaired and 3 bonding for a total of 5. So back to the grocery cart metaphor. B has 3 and D contains 5. So you're going to use all of S first. So S, consider 1. All of your P's, so that gets it to 3. Now you're left with 1 more, so now you're going to go into your D's. And the way that it's written is you write your D's in front. So you're using 1 D, that cancels out that, giving you a hybridization of DsP3 for BrF3.